Welcome back to the PSA BizTech Podcast. Today we'll be discussing the business and technology behind an easier way to program industrial robots for a variety of processes. And to that end, I'm joined by Tom Fuhlbrigge, the CEO of Scalable Robotics. So interestingly enough, Tom is an MIT grad and has over 30 years experience with robotics, most of which has been leading teams to create the next generation solutions for manufacturing and service robotics. He has 75 U.S. patents and over 50 academic papers in a wide range of areas, including bin picking, moving line assembly, small parts assembly, robotic inspection, and making robots easy to use. So now he's making his mark on the robotic automation industry as CEO of Scalable Robotics, which he founded that company in 2019. And as the CEO of Scalable, he is leveraging machine vision and other technologies to provide a code-free, CAD-free, point-and-click programming solution to enable almost anyone to program robots in minutes. So as I mentioned, Tom, you are the CEO of Scalable Robotics, and that was founded in 2019 there on the idea that industrial robots are tools that should be available to everyone, including large, medium, and small enterprises. Many industries face labor shortage, as we'll discuss in a little bit here, and many people are put in harm's way because it's too difficult or costly to program a robot, even though the robot could do the job. So Scalable Robotics is changing that by enabling manufacturers with batch size to easily and cost effectively and safely manufacture today's highly competitive marketplaces. Wow. All right. So to learn more about Scalable Robotics, you can visit their website at www.scalablerobotics.ai, and be sure to follow both Scalable Robotics and Tom Fuhlbrigge on LinkedIn. All right, are we ready to get started here, Tom? How you doing this afternoon, or this morning rather?
Great, Joe. Thanks. Really happy to be here. Thanks for setting this up.
No, I'm super happy that you're able to join us. Certainly, you and I have some experience. Just a fun fact that we spent a few years together at ABB Robotics. Correct? You mean you led the team there at the Corporate Research Center up there in Connecticut, right?
Correct. Yep.
Yeah.
Yeah, I ran the corporate research for robotics here in the U.S. for 13 years.
Yeah. So that's great. So I spent like 12 years at AV. So geez, we almost shared the same amount of time there together. But hey, now you're at Scalable Robotics, which is like really cool. And I've got a history myself in arc welding. Prior to myself joining ABB, I was doing some arc welding automation with OTC Dyhan at the time. So I understand. I mean, I was under the hood. I was actually programming arc welding robots the old traditional way, on the pendant. And
hmm
that was even before simulation technology and all that. So it was really down and dirty with the pendant. So I kind of understand the trials and tribulations here with trying to program robotics, under the gun, on the teach pendant. So really anxious to talk about this new technology you guys have here. So before we do that, though, let's tell our listeners just a little bit more about yourself. Because you're just a fascinating individual here, MIT grad, years of experience. So just shed a little history on yourself and how you kind of got into being the CEO of Scalable Robotics.
Oh, sure. Well, yeah. I did my bachelor's and master's at MIT, and then I was in the Navy for a while after that. So I spent 5 years in the Navy, 3.5 years at sea as an officer on a submarine. So, and if you notice I have white hair, that's really from my Navy days.
Oh,
But when I got out of the Navy, I decided I'd done robotics as in college, and I decided I wanted to get back in robotics. And so in '94, I joined ABB and went in as a development guy, and then I was software engineering manager, and then I spent a couple years in Sweden, actually doing project management in Sweden, and then came back to the U.S., worked in Auburn Hills, ABB again for another year, and then joined ABB's corporate research out in Connecticut here. And then from 2006 to 2019, when I left ABB, I was the manager of the Corporate Research Center for Robotics here in the U.S.
yeah. So then you made that transition, then, right? You left
Yeah,
ABB, and then you started this kickstarted or this Scalable Robotics.
yeah.
What was the driving factor behind that? What was in your mind saying, "Hey, this is something I need to do"?
So in ABB, we had studied usability for a long time in corporate research, and it had been my, very like one of my main drives was to say that, what's holding back industrial robotics from being what it should be, right? And we'd always, my whole career, industrial robotics was coming up, the next best thing, right?
Hmm.
The market should be, much bigger than it actually is.
Hmm.
And we looked at that and we said, well, it's not like robot price. They're really reasonably priced. It's not reliability. It's not capability. They can do all the applications we want. Like I said, the reliability, robot is a 50,000 hour mean time between failure machine, right? It meets all the requirements except for usability. They're really just hard to use, right? There's processes are complicated. Every robot manufacturer has their own interface, has their own programming language, has their own way of doing things. And if you know like an ABB robot and you want to go to program a FANUC robot, it's a completely different world.
Hmm.
Because one doesn't mean you can program the other. They're just so different because they come from different backgrounds, right? They grew up in a
Different
different way.
languages, right? Literally different
Yeah,
languages, right? Yeah.
yeah. And we'd always said in ABB, it's really the usability problem. That's what we have to address, and that's what's holding back robotics. And in the 2000s, 2010s, early 2010s, we really didn't have the technology to really fully address it. And because what we said was, when I was kind of thinking about Scalable, I said, the robot almost knows everything it needs to know, right? We can give it almost all the knowledge just by being there because, we talked about like, context-based robotics and saying, okay, once the robot is in a certain context, meaning what is the end of arm tooling? Like if you give the robot a welding torch, okay, it's not going to do painting or grinding or material handling or any of these other things. So any questions or any interactions you have with the robot are going to be within the context of welding,
Hmm.
right? So we had talked about that and talked about that, and then and in ABB, there's just so many other things to do. It's a vast company. In corporate research, we had so many other projects that were more important than usability.
Hmm.
I mean, we did everything from submarines for inspection of large power transformers, to air gap crawlers for inspection of large motors and generators,
Hmm.
to charging electric vehicles, to uh, bin picking, to teleoperation, all those things where like I have a lot of patents in those areas, and those are all great areas,
Hmm.
right? And really good topics to work on. But my in the back of my mind, I really always wanted to solve that usability problem.
Yeah. So, okay,
So,
so you mentioned patents. So, are all those patents when you were with ABB, or did you have some, prior?
so now we have our own scalable patents. So we
Okay.
have, so as scalable, I have, we have 3 granted patents now. Have a couple more in the works. And that covers the basics of what we're doing. Basically, for us, it's the scanning, teaching, tuning process that we
Hmm.
do.
Okay. Yeah. So those are probably your favorite patents now, right?
They absolutely are, right? And we were really happy to get them because they cover really the core of what we do, and it's super core. Anything, kind of going forward, it's going to use that sort of technique. Uh, One of the investors in my company, he was like, the way I look at it, you guys are inevitable. It's either going to be scalable or somebody just like scalable that's gonna solve the problem. And he says, look at like CNC machines in the 80s, right?
Hmm.
They were really hard to program. You had to program in G code, and you had, so what was that? It meant you were limited to kind of like straight lines or planes or, kind of circles and things like that,
Hmm.
easy curves, right?
Right.
Where nowadays you wouldn't imagine programming a CNC out of Mastercam or out of something else, right? You wouldn't, the G code that they produce is so complex and just so voluminous, right? Just so much of it, right? That you would never think of doing it, right? But it's so
Hmm.
easy, right? So, what they did then is they took a hard to program machine and made it easy to use, easy to program. And he says, you guys are doing the same thing. You're taking a hard to program machine, a robot in this case, and you're making it very, very easy. You don't have to know anything about the code of the machine to be able to program it as if you were an expert.
Hmm. So you had this idea, right? But you had to get the
Yeah.
idea from an idea and then think about bringing it into a company, right? To make it a viable company. How was
Yeah.
that process like for you, going from leaving a corporate structure, then starting your own business, trying to get some partnerships, funding, and all that? Can you walk us through that? Is that okay to do that?
Yeah, it was ours was a little bit of a special situation because me and my co-founder exited ABB. He was one of my managers underneath me uh, in the fall of 2019,
Hmm.
and and we actually incorporated Scalable in November of 2019 and started working on our ideas, and then COVID started in March, right? Basically, really got kicked off in March, right? There, already at Christmas there was right of that year there was hints of something's up, right? And so we we had started talking about what we wanted to do to investors like the VC crowd, and they were kind of like, the world's falling apart. We all of us might die, so we're going to hold on to our money for now.
Oh, jeez.
So we actually got a quiet period to do some, serious development, to develop the minimum viable product, as we called it, right? Just kind of get the ideas down and make sure that it worked.
Hmm.
And then what happened then is we started showing it, and we actually went back to ABB and showed it to them. And we went to the office in Auburn Hills and set up a demo there. And they're like, "Well, this is really surprising." And we're like, "Well, what's surprising about it?" And they said, "Well, it works." I'm like, "What do you mean it works? Of course it works." And they're like, "No, no, you understand. We get guys coming here, companies coming in here all the time to show us demo, and they always kind of work sometimes in a very particular situation. But we did all sorts of things that we had never tested or seen before. Just different parts, just putting them down and
Yeah.
scanning it and teaching them, and doing the tuning and stuff, and it worked. Um, and so that kind of led along. ABB did like an official evaluation on us. They flew over a guy from Germany to sit with us for a week and go through everything in detail. And then that led to a term sheet, which was the investment offer from ABB. And we really chose that in when people are investing in you, it's kind of like people joke, it's kind of like a dating situation. You want to choose somebody that you're comfortable with,
Right.
right? Right. And what I didn't want to have, I wanted a strategic like ABB to help us, right? Lead us along, right? And then, we got a local angel, and then we got Connecticut Innovations, which is a quasi-state thing here in Connecticut, to invest in us. And all these people groups have been really, really helpful, right? They really, CT Innovations really did this thing where they're like, okay, we can help you with your HR, right? Help you hiring people. We can help you get set up with financials. These are the people we recommend you connect with for, just all that kind of like starting a business stuff, which I had never experienced because I spent my career right in ABB. But so they're like, okay, this is who you should talk to. So I would talk to them, right? And that was super helpful, right?
Very,
And
very
then
helpful.
ABB with and what's nice about ABB is having been there for so long, I knew so many people, right? So many of my friends, right? That just, that just would help us. We have a technical issue, you just
Yeah, makes
call
sense.
up, one of your friends from the last 20 years, and they're like, "Oh yeah, this is, they kind of, they'll help you out, right?"
Hmm.
So,
Yeah, we do
so
the same thing
it's
here. We
it's
do the
been a good
same thing here
experience.
too. At PSA, we do the same thing because I have so many friends. If they're still there, hey, call them up. I need some help. So yeah, that's great.
Yeah,
I was thinking
yeah.
that's kind of the reason why you went down the ABB robotics path. Number one, because
Well,
they did invest right in you, and number
yeah,
two, the
yeah, yeah.
familiarity with the product, right, and the
And
interfacing
with the
to it.
product so much because you know me and you know my co-founder, we've been working in the ABB robot world, right? He
Right.
started in ABB in the late 90s. So, I mean, it had been 20 years for him, right? And Carlos actually had been part of the team in Sweden that actually wrote the software for the IRC5 Teach Pendant. So
Oh,
he really understood all the details in there. And so it made doing our ideas on an ABB robot just technically reasonable, right, to
Hmm.
do it all. We knew how to do it, when we went to do it. Where if we'd have tried to do it on some other OEM's robot, it would have been a lot of discovery for us and a lot longer of a period to get to something that was workable.
Okay, so let's talk a little bit about the actual process, the solution that you have. Am I right to click the weld, or is that correct? Is that the new
Yep.
click
So
weld?
yep. So our system consists of a 3D camera that's mounted on the robot, a wand that has basically just a button on it for clicking. For we have it has two buttons: click and undo. Teach and undo, and and a PC that's involved. And what the process is the welder goes up to the robot and he'll set the part on the weld table. Okay, and we define, when you're setting up the system, you define like the region of interest, essentially the volume of interest, as the weld table area, right? And so he can fixture it if he wants, or if it's tacked up and it's heavy, you don't have to fixture it. Um, but if you're going to do more than one of a part, you definitely want to use a little bit of fixturing at least, right? Because you want it to have it somewhat relocatable. But what the process is you tell the robot to scan. It'll scan the part and create the model in the moment. That's why we don't need any CAD, because you create the model in the moment.
Gotcha. And you don't
Okay,
compare it.
and
It's
then
not a
the
comparative. So you're not scanning it,
no,
comparing it to make sure, okay, that's
no,
right. Okay, so
no.
no. Okay.
It's just, and what's nice is that it's the model you get what's on the table in the moment, and you're getting all the other stuff that's around it too. So if you have like clamps, or if you have something else that's sitting on the table, it's all kind of there in the model that comes up, so that it's not like if you programmed in an offline world and brought it to the online world and then they don't match up. There's other stuff, right? You don't have that problem because everything that's
Mm,
there is there. You understand?
yeah.
So
Hmm.
so So, so once you scan it, right, then you say, okay, I want to, you choose, you say, I want to start teaching. You say, I want to do like a fillet weld with these weld parameters, and I want to tune it with either touch sense or laser sensor. And they have different advantages for each, right? Touch sense is essentially free, but the laser, you
Hmm.
can do like thin laps, or you can do, more complicated seams. But anyway, you select what kind of seam you're looking for, whether it's a fillet or a lap or a butt or an outside corner or something like that, right? And then you say start, and what you do is you take your wand and you place it kind of near where it does the wand orientation doesn't matter, but you just place it where you want to the point to be, or the weld, like in this case, you're doing the first point is going to where the weld's going to start, right? And you click it, and the system
Hmm.
will record that point, and then you click where you want your weld points to go. And then when you stop, we'll develop the weld path and we'll show you where all those torches, like virtual torches, are. And then the thing that we do next, the two
Okay.
critical
On the
things are,
computer
one
screen.
is yeah, on the computer screen, is you validate the path. So you're proving out that that path, the robot can actually reach that path without running out of robot joint space, without running out of robot reach, without colliding with anything really. And then once you prove out that you can actually do that path, then it'll also practice an auto tune path. And so and now what's nice about that is you've proved in the virtual world, but against the real parts, that you can actually do that path. And if there's any little issues like, oh, I'm gonna bonk into something on the way in and out, or I can't actually reach that, so let me rotate the torches, the torch orientation, so that I can actually reach that point. You can super easy to fix that in the virtual world, seconds, right, where it would be much more difficult to do it in the real world. So you just kind of make sure everything runs in the virtual world, and then you send it to the robot, and it'll automatically load up on the teach pendant. And then what happens is you go to run it. The first time you run it, it'll say, hey, you haven't tuned this. And you say, okay, so tune it. And what it does is the robot will come down, and because we know what kind of joint it is, right? Say that's a fillet, and we know where the path is, where those points are, we can automatically create a auto tune path. So we actually feel for the part, and then we'll place the torch in the corner, according to whatever your weld specification says, your WPS, right? So like, typically it will place it in the corner at 45 degrees and a 0 liter lag. But if your WPS says 42 with a 5-degree push, we can set it for that. So what we do is because welding is really a high accuracy application, right? The spec is, half a wire width the root of the weld is what is the expectation is for programming. So we can achieve that quite easily without a lot of like, and I'm sure you've done it, Joe, if you program welding, without having your eyeballs in there,
Yeah,
your head right next to the torch trying to squint
correct.
at that wire tip, right? But by doing it automatically, we can set the torch exactly at the angles that you want, right? Exactly in the corner, and you say, does that look good? And you in your mind, you in your with your welder's experience, you might say, well, the base of the metal is a little thicker than the wall, so I'm either gonna come out a little bit or maybe tilt my torch angle up a little bit, my work angle up a little bit, right? But you put in your welder's knowledge for that particular
Hmm.
spot, right? So, and that's a really critical thing, is to be able to have the welder eyeball it and go, yeah, that's what it says, but that's what the spec says, but really I need to do it like this a little bit, right? So really critical to kind of
Okay.
embed that welder's knowledge into the system, into the program you're making. And then for each point that you've taught, it'll do the little dance
Okay.
where it finds it, puts it where the spec says, you say okay, or jog a little bit and say okay, and it goes through, and then you're ready to weld. So any subsequent parts, you don't do that teaching process again. You just put it in, put the part in, and you weld. And
Right.
then one of the really critical things, which was kind of like we thought was a good idea in the beginning, but it's turned out to be one of our main selling points, is this thing we call production tuning. So it turns out that everybody has upstream process issues, right? Everybody's got saw cuts or something like that make the seam wander a bit, right? And one
Hmm.
of the hard parts about arc welding is not getting the robot to where it's supposed to go. So the robot will always go to where it's supposed to go, right? It's getting your part to be in the same spot each time. So in the scalable arc system, you can actually, once you've programmed up a seam, you can actually click on it and say, hey, I want to production tune that seam before I weld it. And so what it will do is the robot will, when you go to run the part, it'll first go and feel for whatever seam. Say you have, like I have one customer that has 31 seams on the part, and 4 of them they need to production tune. So when they go to run the part, it'll first go down, feel for those 4 seams, weld them, and then do the rest. So it's a super handy way of allowing your fixtures to be kind of not as good as they probably should be, or allowing for your kind of normal upstream process variances. Your saw cuts are saw cuts, right? They're always going to be a little bit off.
Right.
So that was kind of a long-winded answer, sorry.
No, no, no. That's quite right because it really is interesting to know how that works. Now, so it is helpful to have. It's kind of helpful to have the operator there, and could be a welder. Now, would you like to take those skill sets and have them become the programmer with the wand and the tools and the software? Is that the idea?
Yeah, it's the welder that's the programmer. So the idea for the welder is he doesn't need any new knowledge coming up to that welding cell other than knowing how to weld. Okay. All he needs to know is, where should the welds go? What do the torch angles look like? And then once you actually weld, do I need more or less wire feed? Do I need more or less voltage? The tuning of the weld itself.
Hmm.
So that's what we've proven out, is that, the welder doesn't need to know anything about robots or robot programming. He just needs to know, you know, where should the welds go in the part. And those are the things he knows anyhow, because he's been welding those parts already. So the three things we really focus on are, one is, you don't have to take the time and cost to turn your welder into a programmer, right? Don't have to send them off to school. Two is, we've shown that it's about an order of magnitude faster compared to manual programming, to do it with the scalable arc. So we have one customer that was, prior to having our system, was taking a whole shift, so 8 hours to program a new part. And one time I was there and I was asking him, so like, how do you plan for the programming of new parts? And they're like, we don't. Like, well, wouldn't it be a best practice if you like put that into the plan? So if you get new parts in, the guy goes, no, we don't need to do it. And I kind of like was pressing the question a bit, thinking it would be a good idea. Look, and he put a new part into the fixture. He goes, time me. And it took him 22 minutes to program the whole new part to production quality. That's tuning and everything, to production quality steam, so he could run it as a product. And it's a 7-minute weld cycle anyhow. So he goes, it doesn't matter. He says it's quick enough that we don't have to do any planning. It's just it just you know if I get a new group of parts in that I haven't done before, I'll just make up the program. It's not a big deal. I'm like, okay, so that was kind of an eye opener for me that it was that much faster. And then the third thing, what I said I mentioned before was already that production tuning because we found that so many people will sit there and they'll kind of just run through the program manually, just kind of step through it and look at their part and touch it up, you know, for every part. And we're like, oh my God, that's really time consuming and hard. And it means you got to have a programmer there all the time. So with us, we said, we can automate that. Just say you want to do a production tune, it'll quick feel for the seam and then weld it, right? And then, so what it gets you is great first pass quality. And another customer that was there a couple months ago now, I was asking him because he does that production tuning on every part, and I said, well, you know, what does that mean for you? And he goes, it saves me 5 to 10 minutes per part. I'm like, so how many parts are you running a day? He goes 50 to 70. And I'm like, okay, so just roughly, if I go 10 minutes and 50 parts, that's 500 minutes. That's a whole man day, right? You know, and and uh, and so we kind of like just back of the envelope said, geez, the scalable system as an add-on to your robotic system paid for itself within the first 4 months. It's like 17 weeks of payoff. It was, you know, he's like, yeah, he goes, it saves a lot of money.
Okay, so yeah, so we were talking about the operator being and the programmer being the welder and such, and we when we got through that, and that was, and I expected that to be the case, that you'd want the actual welder with his knowledge to be the programmer. It would only make sense. I mean, that's the ease of use of the whole thing. But
Right.
are you able to integrate this solution into like other peripherals, like a positioner? Traditionally,
Oh
like a
yeah,
lot of times you have to reposition a part. So is that part
sure.
of the software?
That's one of our main advantages is we support everything that a full-sized robot can do. So positioners, tracks, you know, you want to do weaving, you want to do stitching, you want to do through the arc seam tracking, right? Anything that the ABB robot can do, we support. So that's one of the main kind of things that it was one of our original goals, is to, you know, not be a subset of what it can do, but actually do everything that the robot can do.
Awesome. Now, what if a company has a system already installed, traditional, using Robot Studio or programming? Could you come in and then do a retrofit to
Yeah,
the solution?
absolutely.
Okay.
Right. Yeah. No, we've done that a couple of times now. We had one company that does aluminum MIG, and they make heat exchangers. And their programmer, it was just this year. His programmer left at like right before Christmas, and the robot was sitting just for 3 months. Nobody knew what to do with it. And finally, they contacted us, heard about us, contacted us. We went in, retrofitted Scalable onto the system. As long as it's an IRC5 system, it's okay. We can go back, um, about 15 years easily for the
Oh,
ABB
okay.
robots. And this was an interesting system because it was had two external axes on it, and and now they're running production. They're doing programming. They don't know anything about the rapid language, MEB's robot language. They don't know anything about that, but they're able to program their parts up. It was interesting. We were talking to them a little while ago, and and the guy said, well, he says, well, I'm really new at it. So it's taking me probably an hour to program that part up on the robot. And we said, well, how long would it take you to manually weld? And he goes, oh, about 2 hours. I'm like, oh, so you know,
So I just saved you an hour.
yeah, that was just a program, but the runtime is still like half an hour, right? But
Yeah.
I was like, that the manual welding was taking them a long time because these are heavy welds, so they want to weave, they really got to fill, and they
Hmm.
have to make sure that there's no holes, right? Because this is welding an end tank onto the core, so
Right.
it's got to be a great looking weld, and it does great looking welds.
Yeah, but I mean, once he takes that hour or so to program it,
Yeah,
then you
then
run
he's
them.
good.
It's like
Right, he's
then you're
running, then
done.
he's running.
Then it's process time now from here on
Yeah,
out, right?
yeah,
Yeah,
exactly.
yeah, awesome.
Yeah,
So, are you guys looking at any other processes besides welding for this technology?
absolutely. So it's really any process where the path and the geometry matter. So, so whether it's like adjacencies are dispensing, certainly, right? And then,
Mm,
we could do grinding and polishing, but we already have inquiries for doing cold spray, you know, uh,
mm.
and then, other
Cutting? What
kind
about
of,
like laser cutting, plasma cutting, things like
yep,
that? Water
cutting, yep.
jet cutting?
A lot of those things are more of a 2D thing where you have the pattern that you put in, right? But like plasma cutting's been interesting because we have inquiries because people are interested in doing 3D plasma cutting, where they kind of they'll draw it out on the I-beam and they want to cut that I-beam. And with our system,
Hmm.
they could just teach it and cut it, right?
Hmm.
Where they would have a tough time doing that, otherwise, right?
Right.
Um,
Yeah.
but anything
So,
where it's a continuous process, right? So like for picking and placing things like that, that's not for us, right? Those are
right.
those are those are parts where or processes where the path doesn't matter, just the endpoints matter. And for us, it's all about the path.
All about path. Okay. So how would you guys go to market? Are you doing direct to end customers all yourself,
No,
system builds
no,
and
no,
integration? Okay.
no,
So
not
what's
at
your
all.
mode?
It's always through the integrator.
Okay.
So when we set up the business, we thought about that, and I had done, the integration business when I was in ABB. I'd been part of an integration, business in ABB, and I didn't want to do that again, personally.
Hmm.
I had spent my, 2 weeks at Fort Kansas City programming robots over the Fourth of July holiday, right? I'd done that,
Fun.
and
Fun. Yeah.
yeah,
Right.
and
No, I know that too. Yeah.
yeah,
Yeah.
and and plus I knew, right, a lot of integrators, right? I know these people. I'd been interacting with them through my time in ABB. That's how they would bring customers in with interesting problems that corporate research, would be interested in solving for them. Um, so I already knew a lot of integrators. So we decided that, we were going to stay more of a technology company and go through the integrators to the end customer. So that's what we do. We go through ABB and through the integrators to the end customers. So the first call that comes in is to the integrator, and if there's an issue with the scalable stuff, then you know, and another thing that drove it home in one of our very first systems, we actually did the integration, and I remember things been running for a while, and then one morning at 7:15, I get a text and it says, uh, the curtain's not working, and there's a safety curtain, automatic curtain that comes over, right?
Right. Right.
And I'm like, okay. I text back, did you check the air? And an hour later, I get a text. The robot says the curtain's not working. And I text back, did you check the air? And then 20 minutes later, LOL, the air wasn't on. And I'm like, these these are the kind of calls I don't want early in the morning, right? Because
Yeah.
this is
Right.
one of our very first customers, and I'm like, we're gonna have hundreds of customers. I don't want to have those sorts of because the plan is to scale up, right? We're not doing
Sure.
we're not doing a specific technology in order to sell a system. We're doing a technology in order to really kind of be bigger in the industry, to help the industry to really solve that usability problem. So robots are much more accessible, much more just easy to use once they're integrated into your factory.
Okay, so your value add then is what? It's the little click device, the software solution, and a vision camera,
Yeah.
and then that interface. Is
Yep.
that basically your solution set?
Yeah. Yeah.
Okay, and
And I
so
said,
that's fairly easy to scale then, right? I mean, that's developed then kind of easy to scale, roll out,
oh
working
yeah,
with very
yeah, no,
powerful integrators in the
yeah,
welding space, right? They're
yeah.
really going to help you promote and drive that solution, right?
Right. Yeah. So we sell our kind of our package like a function package in the ABB parlance for the
Hmm.
robot, where it's just got everything you need in our package to install it and set it up. And and because both Carlos and I worked in the integration side of things, we made sure that it's really easy to integrate. So it's like to calibrate the camera to the robot is maybe a 10-minute process. So you don't have to be very,
Mm,
very accurate about anything, because all you have to do is make sure that the camera can kind of see the calibration pattern, and we'll automatically center on it and automatically kind of, figure out what are our calibration, points we have to go through. And so, that's something that we know in the past has taken us a long time when, back years ago when we do other people's vision systems, and we said, okay, we want to make that, just a button push to calibrate.
super
It's,
easy. Yeah.
it's one of those things that you can't make it hard to integrate, right?
Yeah. Is this something that you can order directly from ABB? Meaning they have their FlexArc cells. Is that like
Yes.
somebody like an integrator like PSA? We actually buy FlexArc cells and then we resell them. Okay. And
Yeah.
we don't really get into building end of arm tool or any of that real true hardcore process development, but we can resell and do some programming installation and all that. So that's like a one click, say call ABB and say, hey, we want the scalable option and it can be
Exactly.
delivered that way.
Yeah, it's
Oh,
on
super
it's
cool.
on the checklist, on the cross list.
Awesome.
It's a scalable option. So it's just like if you're ordering, you want your arc welding robot with a certain power supply, right? Then you'd say with the scalable arc option, it's just kind of like
Okay.
that. And
Okay. Awesome.
yeah, and it's and whatever external axes you want, and positioners or whatnot. And yeah, and it's that easy. So it's meant to be easy for the integrator to actually just order also.
Yeah.
If it's a retrofit, then we'll ship the system, our function package to the integrator themselves, and they'll do the
Okay.
install at the customer and do the setup.
Right.
And for the, with our initial, batch of integrators, we're basically helping them do that in the beginning. We'll be there with them for the first one or two, because it's,
Yeah.
it's new, right? And we want it to make sure it goes smoothly. And there's always stuff that we learn that we go, oh, okay, we didn't know that was hard. Okay, we'll make that easier.
Yeah. That's great because we have a lot of solution providers or what we call technical partners that have a certain solution set that, yeah, we're doing the same thing. And because it's new to us, it's their solution set. They kind of work through it with us for the first couple. So, yeah, that's a
Yeah,
great way to do that for your partners. And I'm sure
yeah,
they appreciate it. Are you
yeah.
guys doing Fab Tech coming up this year? Are you going to be in
Yep.
your own booth or in ABB's booth?
No, we'll be in our own booth.
Oh, wow.
And
Okay.
what we've done though this year is we've teamed up with like like three integrators that we commonly use, little geographically separated, but three of the integrators we commonly use, and we have a joint booth together. So what
Okay.
we're trying to do is we're trying to cut the time. Like, we've always done Automate and FabTech. We've done those for the past few years. And in the beginning it was an ABB's booth. The last FabTech and Automate were our own booths. And but the process has always been you get the lead, and then after the show, then you make contact with the lead, and you try to arrange a meeting or visit, and you're trying to put the lead together with the integrator,
Mm-hmm.
right? And so at the Automate show, what we did for a day was one of our integrators, like our normal integrators that we work with, was in the booth with us. And so when the customer said, well, this is my problem, we'd say, okay, well, you're in, Aaron's, in this case, territory, bring him over, and they would talk, and then they would actually make, okay, here's the date that I can come, that the integrator can come visit the plant and see what the actual situation is, and and quickly get from, just from, okay, we have this problem, to a development of a quote, right? So that we can kind of cut through some of the gates in that process that are hard to get through, right?
Yeah, no, that's true. So that's good. Um, because trade shows are always tricky with that. I mean, it's like, yeah,
Yeah,
and especially when you're sharing booths, if not one, but multiple integrators, understanding where they play in what region, that's very important. And then, yeah, divvying them out and getting to them as quick as you can on a follow up. And if you can schedule it right away,
yeah,
only the better. Yeah,
right,
that's
right,
awesome.
yeah,
That's cool. Well,
and
if I travel to any of the trade shows this year, I'm not sure if I'm going to go, to either Automate or FabTech, but if I do, I definitely would love to stop by and check out, the booth and such. So yeah, we're kind of wrapping up here in a little bit, but I always like to end the podcast with a success story. Now, we talked a little bit earlier about the one with the heat exchanger. That certainly was a success story, but is there anything else that comes to mind that is like that helped you scale, that helped you solve a certain problem uh, in this for a particular client that you'd want to share with us?
Um, I shared with the one with the doing the production tuning earlier, and that how that saved him. But there was really another aspect of it that really drove home that the value of that to me was that he said that he's telling me when I was there uh, a previous time, it does this for him. It's he's making these steel frames that have like a motor or generator, or it
Mm,
could be a large motor and a pump. But then you have these steel frames that are the base frames. Um, and he's doing the production tuning in the corners. And he said that if he doesn't lock down those corners and welds the rest of the thing, uh, then when he takes it out of the fixture, it's kind of sprung apart, and they have to basically jack it back together so they can weld those corners up. And so that's why he's doing the production tuning in the corners, because it's plus or minus an eighth, he said. But anyhow, I was there one time, and the system does the production tune and stops. And he goes, "Well, why did it stop?" And I'm like, "Well, it says right here on the pendant that it's 12 millimeters away from the nominal, and the upper limit's set to 10." And he's like, "Well, 12's fine." And I go, "Well, what's your upper limit?" And he goes, "Plus or minus half an inch is good." I'm like,
oh,
"Okay."
geez.
That's a lot for welding, but it's just a fine. And so we put it to 13 millimeters, and it runs through, right? And he goes, "You don't know how important that is to me." And I said, and I'm like, "Oh, well, like why?" He goes, "Because I'm using my old fixtures from my previous system, right? I've had these fixtures for 20 years." And he goes, "If I had to tighten that all up and buy new fixtures," he goes, when we were getting this new system quoted up with ABB and Scalable, we also got a quote for new fixtures. And they wanted 30 grand a fixture for heavier fixtures, right, to make sure the parts are in place. And he goes, "I have 25 fixtures. There's no way I could do that." He goes, "But with Scalable, I don't need them, right? It's just feeling for it. It's, nobody cares if it's a little bit bigger, a little bit smaller, in the outside dimensions, as long as it's welded right, and it is. It's kind of it's pushed together,
Okay.
right? They, all the seams meet
Yeah, the
up. It's not
joint's
like
there, right?
yeah,
The joint's
yeah,
there. It's not like
joints
you're
there,
not like a
right?
big
There's no
gap or
gap.
anything. Yeah.
Yeah,
Yeah.
it's I mean, but just the it's a saw cut buildup, right? Every saw cut's a saw blade width off, right? And you just kind of build it up, and all of a sudden you're you know half an inch,
Wow. Wow.
So, uh,
That's awesome.
but
No, that's great.
that was a like a it kind of drove it home to me how just by enabling some kind of, from our perspective, simple things can are really like make it just super easy to justify buying a system as an add-on to a robot system.
Yeah, so I'm going to keep in mind this whole retrofit because I may have some things that in the works that could help out a few of our clients as well. And interesting, I'm going to continue following this, but Tom, I got to wrap it up here. I'm super glad that you're able to join me on the podcast, and wish you all the best. But before we go, how can people get a hold of you or your company? What how can they get a hold of you?
Um, Through the website, you can make inquiries to the website. There's a method on the website. You can call us. You can contact us through ABB. You can contact us through various integrators. Ask if you you are an integrator, but if the customer out there has an integrator that they because we go through the integrators, right? If they have an integrator that they normally use, just ask them to contact us. But it's there's many ways.
Well, that's great. So, for all the listeners out there, absolutely reach out. If you're welding and you're having issues finding people to program your robots, reach out to Scalable because they're going to be able to help you, right?
Right.
Awesome. Hey, Tom, thanks a whole bunch. Again, best of luck and the continued success, and look forward to seeing you soon. Thanks a bunch.
Yeah. Thanks, Joe. I really appreciate it.